So with this expression, I can see that I've got two big terms here. So I've got sort of one term here, and I've got one term here. So I'm going to pick a term to start simplifying first. So I think this one looks quite nice here, because there's a number here. So I'm going to deal with that first and get it out of the way. So y or 1 will be just 1, because if y is 0 or 1, there's still a 1 here, so anything or 1 will be 1. Not x and 1 will just be not x. X or not x will have to be 1, because if x is 0, not x will have to be 1, and if x is 1, not x will be 0, so there's at least 1 there. 1, 1. And z and 1 is obviously z, so we can get rid of this here. Let's just get rid of that. So let's sort out this term here. So we don't have to De Morgan it straight away. Let's just try to think of what we can do inside this term. So we can leave this line at the top here. I can see that in this term there's y repeating. We've got y repeating in these two little terms here. So I'm going to take out y, because that will leave us with z or not z. So we know z or not z will just be 1. We know y and 1 will be y. Now here, we're in a position where we can apply De Morgan's law now, because we can't really do anything inside this term. So let's do that. So not x will be x. Not all will be and not y will be not y. And then we've got the plus z. And we can just leave it like that. So here we got another strange looking Boolean expression going on. So I'm not going to apply De Morgan's law straight away, because I think there's things we can do with these numbers here that are in our terms. So I'm going to deal with them first. So x or 1 will just be 1, because no matter what x is, there's still a 1 there, and anything or 1 will just be 1. Now y or 0 will be y, because it depends on what y is, whether it is a 0 or 1 as the result. So let's deal with this number over here. So x and 1 will just be x. And now we can't really do anything more here, so we're in a position to apply our De Morgan's law. So let's go ahead and do that. Not x is x. Not and is or. Not y is y. Not x is x. Not or is and not y is y. Now let's put brackets around here, because this was one term before, just so we don't confuse ourselves. And I'm going to rearrange this, because I prefer to have the thing outside the brackets on the left hand side. So let's go ahead and expand this bracket. So we've got two terms here. We've got two x's in this term, and we've got two y's in this term. X and x will just be x, and y will just be y. So we got this. We've got this right here. So these two terms are obviously the same. So one term or another term, as we know, will just simplify to this. That's basically like A dot A or A equals A. That's the proof there for that. So that will be our answer right here.